Today's lesson, section 12.1b, we'll still be talking about sequences in summation notation. Also, we'll be talking about arithmetic sequences. So example 6 here wants us to write the sum using sigma notation where the index of the summation k runs 1 to 7. Okay, so that just means your starting point will be 1, so start, and then your 7 will be the end. Okay, so it's like your end value up there. So the first thing we would write our summation is 7, and then k equals 1. So now we have to write a formula that represents what's going on down here for our sum. So it looks like the first number should be 3, goes all the way to 9. The thing that doesn't change is that it is always to a power of 4. So it should be something to the 4th power. And so now, how would you go from the starting point of 1 to get to 3 is the next question. So taking a k value for 1, so I'd have to add 2 to it to make it 3. And it looks like every time, if I move to the second one, 2 plus 2 gets me 4, 3 plus 2 gets me 5, 4 plus 2 gets me 6, and it looks like I can get to 7 plus 2 gives me 9. So I should just do k plus 2 in this formula area, and then I should have my equation. Okay, and make sure you check, but it looks like ours does match. Okay, now there are some other properties of sums that we need to talk about, especially when you're looking to find the sum with more difficult ones. So if you have two sequences for a and b, and for every positive integer n and any real number c, these following properties hold true. Okay, so if you have a summation notation of two different formulas that are added together, or either if they're like two different terms, so like it could be like what we did on the last video is 2k plus 3. I could have separated those because of the addition and created one where it's just 2k and plus 3. Okay, and so for that one you would have had the same answer, it's just a different way of writing it, maybe breaking it down so it's less difficult to put all your stuff together. Okay, 2 says the same thing, but it's for subtraction, so you can separate them into two different things based on the subtraction. And then also, if you have a multiple or a scalar multiplied to your formula, you can move that out, so you can put it out front and say c times whatever it is, so you can find your sum, and then at the end you can take that number times 2, or times whatever c is. Okay, so those are different formulas that you can use to kind of help you out to make those sums a little less arduous. Now the second thing we want to talk about is arithmetic sequences. So an arithmetic sequence is a sequence of form, so you start with a, and then the next term is a plus d, and the next term is a plus 2d, and then so on and so forth. So a plus 3d, a plus 4d, so on. Okay, so the first number is the first term, so that's representing a, and then the d is our common difference, so it's like kind of like a linear function. So if you had 2x plus 5, your starting term is 5, and then if you plug in the next term, then it gets you, it would get you 7 in that case, and then you would get 9 because you're going up. The common difference is 2 in each one because of that slope. Okay, so each equation that we're going to write for arithmetic sequences is in the form of a sub m is going to equal a plus n minus 1 times d. Okay, so here we want to be able to find the nth term, so meaning the formula of the arithmetic sequence 9, 4, negative 1, negative 6, negative 11. Okay, so the first things we need to do is find a and find d, and then we just get to plug them in. So a is the first term, so it looks like the first term is 9. Okay, it's not the smallest term, it's always just the first one in the sequence, so where you're starting at. D, so looking from 9 to 5, or 9 to 4, it looks like you subtract 5, and then 4 minus 5 would get you negative 1. Negative 1 minus 5 would get you negative 6. Negative 6 minus 11 would get you negative 5. Okay, so, negative 6 minus 5 would get you negative 11. So then our common difference must be negative 5, So then a sub n will be 9 plus n minus 1 times negative 5. Now you can also write that differently. You don't have to put the d in the back. So you can say this as well. These two are equal and the same. Okay? But that's kind of what we're looking for arithmetic sequences. In the next video, we'll do more with these and kind of look at some different stuff. Okay? Have fun.